Right, so just a quick run through on how to answer questions on free body diagrams and calculations. Please have a go at these yourself. Only watch or continue to watch this video to check the answers or if you get stuck. So it says the box below is floating on the surface of the water. Complete the free body diagram. So it asks us to calculate the mass of the box. So what we've got to do is rearrange that equation for mass. But before we do that, we will see phi for it just to make it all clear. So C, F, I, F, A. So we need to convert because we've got the weight, that's the weight of the box. Because remember, force and weight are essentially the same thing because weight is just the force of gravity acting downwards. So this arrow could be labelled as weight, okay, which is a type of force measured in newtons. Now our weight is 5 kilonewtons, so that is 5 times 10 to the 3 if you remember your ultimate weapon, which is 5,000. So we know that we have to do 5 times 10 to the 3 gives us 5,000 newtons. Okay, our formula is weight equals mass times gravitational field strength. If we insert our information, 5, okay, just there. So 1 centimetre equals 5,000 newtons. So that means the weight isn't necessarily 5,000 because we've got to measure it and see how many centimetres it is. Okay, so here we can see we've measured it. You'll get a ruler in your exam, and this arrow is exactly 3.5 centimetres. So what we now do is 3.5 times by 5,000, okay? And then if we do 3.5 times by 5,000, that gives us 17,500. Now that is our weight, okay? So we would do 17,500 equals our mass, which we want to work out, times by our gravitational field strength, which is 9.8. Then we need to rearrange it. Okay, so we're timesing by 9.8, so we divide by 9.8. 17,500 divided by 9.8 gives us m. So then if we just do that on the calculator, 17,500 divided by 9.8, that gives us 1,785.7. Okay, so our answer is 1785.7 kilograms because our mass is always measured in kilograms. That's our answer. Right, let's have a go at the next one. Please pause this now. Have a go at the next one once you've seen that. So, same idea again, see phi for it. That way we don't make any mistakes. So, we've got 5,000 newtons again, because it's 5 times 10 to the 3, because it's 5 kilonewtons, which is 5,000 newtons. Now we've got a long arrow again, so in this case, because it says 1 centimetre equals 5,000 newtons, what we've got to do is measure it. So we've got to measure it as accurate as we can. Okay, so we put that on there, and that is 5.5, 5.6, probably about 5.7. So then we would do 5.7 times by 5,000. Okay, double check that. I'm just gone mad. Yeah. And then we do that and we type that in. So we got 5.7 times by 5,000 equals 28,500. 28,500 newtons. Right, now we put our formula in, same as before. Weight equals mass times gravity. We insert our numbers in. So 28,500 equals our mass, because we want to work out our mass again, so we put that as m, times by g, which is our gravitational field strength. Okay, I don't know why I put that as a g, it should be 9.8. Then we rearrange. Now again, because we're timesing by 9.8, we want to get m on its own, we divide by 9.8. Whatever we do on this side, we also do on the other. So it works out like this: 28,500 divided by 9.8 gives us m. So we've already got 28,500 divided by 9.8 gives us 2,908.2 if we round it. Okay, so 2,908.2 kilograms. Okay, now this is a slightly different one. We've got to work out the resultant force from the diagram, because it says resultant force equals mass times acceleration. It actually asks us to calculate the acceleration in this case. So we know the mass and we've got to work out the resultant force. So again, it's still 1 centimetre equals 5 kilonewtons. So we go C phi for it, like so. But we've got to work out the resultant force. So that's the difference between the two. Okay, so it's easier just to work out the difference between the two in centimetres first. So if we start from the tip and go to the middle, that's 1.5, 1.6. So that's 1.6 centimetres is that arrow. And then we're starting from the centre and we're going to here. I would say that is 3 centimetres. So if we do 3, take away 1.6 centimetres, because that's the resultant force, the difference between the two. Okay, that gives us 1.4 centimetres. So the difference between the two, or the resultant force, or the resultant distance between the two is 1.4 centimetres. Then all we have to do is 1.4 centimetres. Don't forget it's 5,000 newtons, so it's 5 times 10 to the 3 equals 5,000. And then you do the 5,000 times by 1.4. And if we do that on the calculator, 5,000 times by 1.4 gives us 7,000. Okay, so we've got 7,000 Newton resultant force. Now we put our formula in. So we've got force equals mass times acceleration. We replace our letters with numbers. So 7,000 equals our mass, which is 5, times by acceleration. Here we're timesing by 5. Okay, so if we divide by 5 on both sides, that gives us A on its own. So we do 7,000 divided by 5. That gives us our answer. So we've got 7,000, and we divide that by 5 because that's the mass. That gives us 1,400 or 1,400, and because we're after acceleration, it's meters per second squared. You just need to remember your units. Let's have a look at some past exam questions. So it says, what is happening to the speed of the skydiver at 2 seconds on the graph? So we look at 2 seconds on the graph, which is there. That's where 2 seconds is. And what we can see is, at this point, the line is getting steeper. Okay, so it starts off shallow, it's getting steeper and steeper, which means on a distance time graph, it's accelerating. Because the steeper the line, the faster it moves. And because the line is getting steeper, the speed is getting faster. Okay. Now, if we look at question 5, it says a skydiver is accelerating downwards. Complete the free body diagram to show the forces acting on the skydiver. So skydivers falling. If they're speeding up, the force has to be bigger going down. So we know this is 3 squares up. So we draw a free body diagram to draw an arrow downwards that's more than 3 squares. As long as it's more than 3 squares, you'll get the mark. And don't forget to label the arrow as weight, and that'll get you 2 marks. So remember, if a skydiver is moving at a constant speed, both forces will be equal. So what I'm going to do is draw these arrows exactly the same. And how I draw them exactly the same is measure both. So that's 1.1, so I need to draw this one as 1.1. And that shows a skydiver going at constant speed, which we call terminal velocity. This is a skydiver accelerating because it's got more force downwards. And if it was a skydiver that was slowing down after they opened their parachute, okay, you'd have the same force going down, but there would be a bigger force going up. So this is slowing down, and this one is speeding up. Okay, right, so this is what you get the marks for: drawing the arrow longer and labelling weight on the bottom. Right, let's have a look at this one. Sorry about how small it is. So we've got a boat, okay? It says, shows a boat floating on the sea. The boat is stationary, so it's floating, but it's not moving. Complete, figure 9 shows part of the free body diagram for the boat. Complete the free body diagram. So it's not moving left and right, so we don't need any forces left or right. And it's floating, so it's not sinking and it's not going up, which means the forces must be equal on it, okay? Because it's like being balanced on the water. So what we have to do is take this, and to get exactly the same, we have to measure this bottom one, which on this piece of paper comes out as 3.9. So that means we have to draw 3.9, an arrow 3.9, exactly straight up on the other one, there. And we label that as up thrust, because when water pushes things up, okay, we call it up thrust. Think of a football being pushed underwater. You push it underwater, it pops back up again. Same with a boat. If you could push the boat down, it would pop back up again. We call that up thrust. Now we use that information to complete this question. It says, just here, it says, calculate the mass of the boat, use the information in figure 9, gravitational field strength is 9.8. So this is exactly the same as what we did before, but we'll have to get the equation ourselves. So it's C FIFA, and we've got to think, right, what have we got? Well, we've got weight and we've got gravitational field strength. So the obvious equation that we would use is weight equals mass times gravitational field strength, because we want mass, we're given gravitational field strength, and we're given weight. Here it says 1 centimetre equals 5 kilonewtons. So first of all, we've got to convert. So we do 5 times 10 to the 3. Remember, it's 10 to the 3 because it's K. And if you remember your alter weapon, it's that. So 5 times 10 to the 3 is 5,000 newtons. Then we've got to measure, because it says 1 centimetre equals 5,000 newtons, but we want the length of the arrow. So if we measure the length of the arrow, it's 3.9. Okay, so we would do 5,000 newtons times by 3.9. If we do that, 5,000 times by 3.9, that gives us 19,500 newtons. Okay, so now we know the weight is 19,500 newtons. We also know that the gravitational field strength is 9.8. So we put 9.8 there. And the mass is the thing we're trying to work out. Now, because we're timesing by 9.8, we can divide by 9.8 on both sides to get m on its own. So we've got 19,500 divided by 9.8. Okay, and that gives us m. And if we do that on the calc, 19,500 divided by 9.8 gives us 1989.8 if we round it. So 1989.8 kilograms. And there's your answer. And that's it for free body diagrams and calculations.